whereas external bus will helps to connect the external devices, whereas internal bus helps to connect the internal devices like processor, memory, input, output, all those things here it will connect. When you switch on the system, on that time it will take little bit of time, is it to switch on? That time can be called as booting time. If I want to run the system, then must and should we need power supply to all the components of the computer. Welcome back to One and All. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we are going to start with the fourth session of typical configuration of computer system. Whereas in the previous class, already I studied regarding input-output ports. Under that, what do you mean by input ports? What do you mean by output ports? Which are the different types of ports? What is the main use of ports? Regarding that, already you came to know. Whereas in today's class, you will come to know what do you mean by bus system? Why we require bus? Which are the types of bus, that is internal bus, external bus? Then what do you mean by memory? How the memory will store the data? Which are the types of memory? Cache memory, primary memory, as well as how much of power is required, how power will be supplied to all the components of the computer. Regarding you will come to know on this session, that is power supply. Now one by one we'll discuss. The first one is bus system. Why we required bus? Bus is a collection of parallel wires. It is a collection of parallel wires that forms a pathway to carry address, data as well as control signals. It's a pathway. Through that, the data, control, signals, everything will transfer from one component of the computer to another component of the computer. For example, when I'm going to give the data, that data will has to store on the memory. That will transfer by this bus. Usually, in general bus, what is the main use of bus? It will transfer the people from one place to another place. In the same way, here also the system bus helps to transfer mainly address, data as well as control signals from one part of the computer to another part of the computer. Buses are a pair of wires or circuitry which is used to transfer the data. Data it will transfer, controls it will transfer as well as signals also it will transfer. It is the capacity of the bus. Depending upon the capacity, if we have more buses or the capacity of the bus is more, then obviously the execution of the process is also increases. It will be more. For example, in the bus, if we transfer more people, then the capacity of the bus will be more. Then in a limited time, we can able to transfer the people from one place to another place. In the same way, if the bus capacity is more, obviously the execution process is also fast here. Speed of bus, rate at which data is transferred. Depending upon that, we will decide which type of bus here, and it can be measured in terms of megahertz. Consider we have bus, address bus, control bus as well as data bus. In CPU also, the data has to be transferred. In memory also, the data has to be transferred to control unit, address bus as well as data bus, as well as input-output units. There also, it has to transfer the data, signals, controls, all the things to all the buses. Now, is it clear? Next, when we come on types of bus, there are two types. One is internal bus and one more is external bus. There are two types of bus. One is internal bus and one more is external bus. Whereas internal bus connects the major components. Internal bus connects major components like processor, memory as well as input-output. Major components like processor as well as memory it will connect. But when they come on external bus, the external bus connects external devices, additional devices, peripherals, expansion slots as well as input-output ports. Here it will transfer the data. When they come on internal bus, it is also called as system bus also because it will transfers all the data in between the processor, memory as well as input-output ports. When they come on, there are types of bus, especially under internal bus we have three types. data bus, address bus as well as control bus. Whereas data bus helps to transfer the data, whereas address bus helps to transfer the address of the data where exactly in the memory the data is present, and control bus helps to control the data. These are the three types under internal bus. Whereas external bus will helps to connect the external devices, whereas internal bus helps to connect the internal devices like processor, memory, input, output, all those things here it will connect. When they come on data bus, already I told you in the previous class, that is when you come on bus, there are three types: data bus, address bus as well as control bus. Whereas now data bus mainly it provides or it will transfer data. Data bus, the name itself suggesting data bus. It means that it will transfer mainly the data. It transfers data between CPU as well as memory. In between CPU and memory is data is transferred by using data bus. And it consists of 32, 64 and 128 lines of wires it consists. But when they come on address bus, the name itself suggesting it will transfer the address of the data. For example, consider you have huge data in the memory. On exactly on which place the data is present. Regarding that, it will going to tell you regarding the address. Address bus helps to transfer the address of the data, where exactly the data is present. It transfers address of the data. It connects CPU as well as RAM. It determines the maximum number of memory locations the computers can address. And PCs presently have a bus speed between 100 to 400 Hz. Usually the speed of that bus is 100 to 1000 megahertz. Then when they come on control bus, the mainly it will transfer the control signals, where exactly the signal has to be passed, when the data it has to be passed, and when we are not supposed to transfer the data, everything. It mainly controls the signals. These are the three types under internal bus. Whereas external bus helps to connect only the external devices. Whereas internal bus helps to connect the internal components like CPU, memory as well as input-output units. Next, we'll discuss about memory. What do you mean by memory? Why we require memory? In the first class, we explained regarding the block diagram of computer. On that block diagram, we explained input device, output device, memory unit as well as CPU. Then why we required memory? Memory is required for storage purpose. Storing of data. For that purpose, we required memory. When they come on memory, there are two types. One is primary memory and one more is secondary memory. Then already I told you memory is required for storage purpose. It stores both input data as well as output data also it will store. That is, it will store data as well as information. Whatever thing the data is transferred from the user to the computer, that also it will store. After processing, whatever result it generates, that also it will store. It stores both input data as well as information. Whereas computer memory refers to the electronic storage space for instructions and data. It's a storage place. Memory is a storage place. There we can store all the information, data, everything we can able to store. Computer processor has very limited memory. In the processor, we have limited memory. That's why we need the secondary storage device also. Memory can be have two types. They are internal memory as well as secondary memory. Primary memory as well as secondary memory. Internal memory we can say, otherwise primary memory, and then one more is secondary memory. Whereas primary memory is very fast by nature, but it can store limited data for limited period of time. Whereas secondary memory can be called as permanent memory because it stores the data permanently for future purpose. But the speed of primary memory is very fast. When they come on internal memory, it includes the register, cache memory as well as primary memory. Under internal memory only we have primary memory also. Whereas a register is a high-speed memory which stores intermediate data. It is a very high-speed memory, but here we used to say it stores intermediate data. Then what do you mean by this intermediate data? For example, consider we have one memory place A and one more place B. On this we have the value 10 and here we have value 20. For example, I want to swap the value, otherwise I want to interchange the values. Then what we will do, we will take one temporary place. In first iteration, whatever value here, the 10 we will move here. Then now this place become free. Then whatever value in the B, that we will move here. Now this place is free. Then afterwards, whatever value, the temporary place in that we will move here. Now this place is free. That means at the processing time, whatever results are generated, that results can be called as intermediate data. On this case, when we are swapping the value, we need some place, some values are generated. Here that can be called as intermediate data. Whereas register is a high-speed memory which stores intermediate data. Next, we'll discuss about cache memory. Why we require cache memory? Cache memory is a high-speed memory available inside the CPU to speed up access of data and instruction stored in RAM memory. In this register, it stores intermediate data as well as it is very fast. But when we come on cache memory is also an high-speed memory. But it will not store intermediate data on that place. It will store the recent data which we have, which we recently used. For example, consider when we come on cache, there are two types of cache, L1 cache as well as L2 cache. The L1 cache is present inside the processor only. Inside the processor only, the L1 cache is there. On that we have register also. But L2 cache is present in between processor as well as memory. L2 cache is present between processor as well as the main memory. For example, consider this processor wants some data which is present in the memory. First, what it will do? The processor will request the data with the memory. First, it will send the request, I want so and so data to the memory. Then from memory, the data will transfer to the processor. While transferring the data, it will transfer through cache memory, whereas this cache memory will store the copy of the data and then it will send the data to the processor. Consider here, processor wants some data, it requests the data on the memory will transfer the data to the processor for processing purpose. While transferring the data, it will transfer through cache memory. This cache memory will store the copy of the data and then it will send the data to the processor. Consider this processor have done all the work. Once again, if the processor wants the same data, then it will not going to ask the data on the memory. Here in the cache memory only it will going to access the data, because in the cache memory it stores the copy of the data. That's why the speed is high. Once again, no need to request in the memory. Directly it will take the data from the cache memory only. That's why the speed of cache memory is more here. Cache memory is a high speed memory. But when they come on register, it stores intermediate data. There also it is very fast. But there it will store intermediate data. Whereas cache memory stores, they are not the intermediate data. Whatever data we are transferring from memory to processor, on that time, while transferring, it stores the copy of the data. That's why once again the processor, if it wants the same data, it will not go to ask through the main memory. Directly it will take the data from cache memory. It's a high-speed memory available inside CPU to speed up access of data. If processor wants the data, then no need to ask here. Here only it will take the data. That's why the speed is also more here. Now is it clear? The difference between cache memory as well as register. Register is also high memory, high speed memory. Cache memory is also a high speed memory. But in register, it stores intermediate data. Whereas in cache memory, it stores the recent data which we have transferred to the processor. Okay, now is it clear? In the exam, you are going to get the question, what do you mean by cache memory? Which are the types of cache memory? Where exactly the cache memory is present? What are the major functionalities of cache memory? Regarding that, you may going to get the question. There are two types of cache memory, L1 and L2. L1 present inside the processor only, but L2 present in between processor as well as memory. Now is it clear for all of you? Next, we will move on primary memory. What do you mean by this primary memory? Primary memory is also known as main memory. Primary memory is also known as main memory, and primary memory is of two types. One is RAM and one more is ROM. RAM stands for random access memory, because in the exam you are going to get the question expand RAM, expand ROM, whereas RAM stands for random access memory, whereas ROM stands for read only memory. Then what is the major difference between RAM and ROM? When they come on difference, RAM, random access memory, faster memory, whereas ROM is small memory, as well faster as well as here small or limited only it can store. Temporary memory. Then what do you mean by temporary memory? When they come on ROM, it's a permanent memory we used to see. Then what is the major difference between primary memory as well as secondary memory? But when they come on primary memory, on that time, the recent data, recent applications, whatever we are recently using, that it will store. Whereas secondary memory stores the data permanently for future purpose. When you switch on the system, on that time, it will take little bit of time, is it no, to switch on? That time can be called as booting time. On that booting time, the data will transfer from secondary memory to primary memory for processing purpose. But data permanently will store on secondary. When you switch on the system, on that time, the data will transfer from secondary memory to primary memory. But when you come on primary memory, RAM as well as ROM is there. Whereas RAM, random access memory, ROM is read only memory. The name itself suggesting read only memory. It means that whatever thing in that we can able to read. How many times we want, that many times we can able to read on that. But we cannot able to write on that. Whereas in random access memory, there we can able to read as well as write also. Whatever content we want, that content we can able to read. How many times we want, we can able to read. How many times we can want, we can able to write on that. Whereas ROM, there we can able to just read only. That's why here it can be called as volatile memory, whereas ROM is called as non-volatile memory. In the exam, you may want to get the question, what do you mean by volatile as well as non-volatile memory? When they come on volatile memory, here volatile memory means as long as the power supply is there, the data will be there. Once the power goes off, the data will be erased here. But when they come on non-volatile, if power supply is there or not, whatever may be, the data will remain permanently. That's why it is called as permanent memory. Whereas RAM is volatile memory. Volatile is nothing but as long as the power supply is there, the data will be there. Once the power goes off, the data will be erased. Whereas non-volatile means if power is there or off, whatever may be, the data will be remains permanently. Now is it clear? This is the main difference between RAM as well as ROM. In the exam, you may going to get the question, write the difference between RAM and ROM, or expand RAM, expand ROM, or what do you mean by volatile memory, or what do you mean by non-volatile memory. Now is it clear? Next, we'll discuss about the types of RAM. And the primary memory, already I told you, two types, RAM and ROM. But now we are discussing about the types of RAM. Under that, we have DRAM, SRAM, SDRAM, DDR, SDRAM. Then, what do you mean by DRAM? DRAM uses transistor and capacitors. DRAM mainly uses transistors and capacitor. It must be refreshed continuously every time after each transaction. We have to refresh every time in this DRAM. That is dynamic random access memory. DRAM stands for dynamic random access memory. Every time we have to refresh after each and every transaction, we have to refresh here. But the second one, SRAM. Here, Whereas in DRAM, it consists of transistor as well as capacitor, whereas SRAM consists multiple transistors only. It consists multiple transistor, need not to be refreshed every time. No need to refresh, the data automatically restore all the transaction easily we can able to perform. Whereas in DRAM, it is very slow, and with that every time we have to refresh, whereas here no need to refresh, it is very faster. But here it made up from transistor as well as capacitor, whereas SRAM, that is made up from multiple transistors only. Now is it clear? And the next one, SDRAM. SDRAM, that is synchronous dynamic random access memory. SRAM, static random access memory. Whereas the next one, SDRAM, that is synchronous dynamic random access memory. First one, dynamic random access memory. Here, static random access memory. Whereas SDRAM stands for synchronous dynamic random access memory. Whereas it synchronizes to the system clock. It means that it will speed the performance of the processor. It increases the efficiency by reducing CPU waiting time. Mainly, it will reduce the CPU waiting time. By that, the processor will increases. The name itself suggesting that synchronous dynamic random access memory. And the last one, DDR SDRAM, that is double data rate synchronous dynamic random access memory. Here, the data rate transferred is double compared to SDRAM. The name itself suggesting DDR, that is double data rate synchronous dynamic random access memory. Usually, they will ask the expansion. DRAM stands for dynamic random access memory. SRAM stands for static random access memory. SDRAM stands for synchronous dynamic random access memory. DDR SDRAM stands for double data rate synchronous dynamic random access memory. Whereas here it consists transistor capacitor, whereas SRAM consists multiple transistor. SDRAM mainly for synchronization purpose to reduce the CPU waiting time, increase the processing time. For that purpose, we need SDRAM. Whereas double data rate synchronous dynamic random access memory is double rate compared to SDRAM. These are the few types of RAM. Now it's clear. Next, we'll discuss the types of ROM. Then, what do you mean by this types of ROM? When we come on types of ROM, the first one we have PROM, EPROM, EEPROM. PROM stands for programmable read-only memory. At the time of programming only, we can able to read here. We can able to write. Afterwards, we cannot able to write anything on that. Whereas erasable programmable read-only memory, here we can able to erase whatever data in that we can able to erase, and then we can able to rewrite. Then electrically erasable programmable read-only memory. The last one is electrically erasable programmable read-only memory. That means by using electric signals, we can able to erase the data and then we can able to rewrite here. Now is it clear? Next, we'll discuss about the power supply. If I want to run the system, then must and should we need power supply to all the components of the computer. The power supply can be done in two methods. One is by using SMPS as well as UPS. Power supply, that is electric power, is main source of power to the computer. If I want to supply power, in two ways we can supply. One by using SMPS as well as UPS. SMPS stands for switch mode power supply, whereas UPS means uninterruptible power supply. Now one by one we will discuss. SMPS stands for switch mode power supply. This is the SMPS component. When you open the CPU, there inside the motherboard, there you will get this SMPS. This will supplies power. See, here we have several wires. Through that, the data, signals, especially power will be supplied here to all the components of the computer. That done by this SMPS. It transfers power from a source like main power to a load switch to a PC. all the components. For all the components of the computer, we can able to supply the power. And it converts AC current to DC current. This converts AC current to DC current. The main work of SMPS is to supply power to all the components. In the motherboard, we have components, for all the components in CPU, as well as for primary memory, secondary memory, for everything. This SMPS only will transfer the power. Now is it clear? Next, we will discuss about UPS. UPS stands for uninterruptible power supply. Uninterruptible power supply. Then what is the main use of this UPS? When you don't have the main power source, on that time, here it will supply the power. That is UPS. Whereas when you come on UPS, there are two types, offline UPS as well as online UPS also. But UPS provides emergency power to a load when input power source, typically main power, fails. When there is a failure in the main power, on that time this UPS will supply the power. UPS is typically used to protect hardware. Why we require this UPS first of all? If power fails suddenly, then for all the components, suddenly the power is also fails. Then there is a corruption will occur and sometimes the system will not work properly. To avoid that, we need continuous power supply. That's why we need this UPS. Use it to protect hardware such as computer, data centers, everything, telecommunication equipment, all the components, we need UPS. That only, by UPS only, we can able to supply power continuously to all the components of the computer. But when you come on types of UPS, there are two types, online UPS as well as offline UPS. Online as well as offline UPS. Whereas online provides continuously power supply from its own inverter even when there is a main power line is functioning properly. What do you mean by this? Consider we have one converter. Consider we have main power supply here. From main power supply, it will transfer the power to the controller. From this only, we are getting the power to our system. Continuously from its own converter only, it will supply. When there is main power, on that case also, from its own converter only, here it will supply. Continuous, without any break. All the time, we will get the power. If the main power is off, then without knowing whether it's a main power is or a UPS power, without knowing that also, continuously we are getting the power. That is online UPS. Whereas offline UPS, there first we have the main power. From that main power, we are getting the source power. Whenever the main power fails on that time by its converter, then later on it will transfer the power. Andre, ಇಲ್ಲಿ continuous ಆಗಿ by its own converter, continuously it will provide the power. Whereas here, on this case, especially in offline, it will supply the power from the main power only. When there is a failure in the main power, then it will take a milliseconds. We need some few seconds. Afterwards, after recognizing when the main power is failed, then only it will supply the power to your system. That means offline power line is switched over to a battery power as soon as power failure takes place. When there is a main power fails, only on that time it will switch over to the battery for supplying power. And it takes several milliseconds to switch over because here it will not transfer the power directly. Whenever there is a failure, only on that time it will transfer the data. But to transferring the data, it takes milliseconds. Whereas here in online UPS, we are getting continuous power supply. Now is it clear for all of you? Next class, we will meet with one more new chapter. Thank you for all of you.